Good morning and good afternoon. So we are continuing our study on graphing linear equations. And if you remember where we left off in the last lesson, it was the idea that we could always make a table for graphing our linear equations, but that we really don't want to because it takes a long time to graph something that's actually fairly simple. It's just a line. There's got to be a quicker and easier way to graph the line. And there are a couple of shortcuts for graphing lines. So we're going to explore one of those shortcuts. But if you have never had me before, you should know now, I am not the teacher that's all about showing you the quick shortcut to get the right answer and then we move on. I want you to understand why shortcuts work, because sometimes they don't work. And sometimes you'll forget those shortcuts and then you need to go back to those basics. So we are going to explore what it is to graph something using the slope and the y-intercept. Okay, how can we use the slope and the y-intercept? We talked about those in a previous class. So let's take a look at... we're going to put we'll put the coordinate plane up there. That looks good. So we are going to start with our first example, which is to graph the line y equals -1/2 x plus 1. And what I am going to do is give you the steps and then graph the line as I'm giving you the steps. So this is a 3-step process. And what I will probably do is do some scratch work on this slide and then comment on it and then erase that scratch work. So refer back to the video, go to the video file if it will help you later or if you miss something. If I am doing a PowerPoint for this, I will try to make sure that I screenshot those steps along the way. So the first step in doing this is to plot the y-intercept. That says y-intercept. You probably can't tell. Okay, plot the y-intercept. So before we go and launch ahead and do that, let's talk a little bit of vocab. What is the y-intercept? Well, if you think of the word intercept, if you think of it in like maybe football, if there's an interception, there's an idea of crossing the path. Like if an interception happens, the opponent has crossed the path of the ball and stopped it from getting to where it wants to go. So you get this idea of crossing the path. This right here is your y-axis. The y-intercept is defined as the point. So it is an actual point. It's not a number. And if you had Miss Braswell, she would emphasize this. It is the point where the graph crosses the y-axis. So the y part of y-intercept is that it's crossing the y-axis. The intercept part is the idea that your graph is crossing. So if I have a line, the y-intercept is that particular point there. It's where the line or the graph crosses the y-axis. Now, the coordinates of that point, if you look at where it is, the y-intercept will always have an x-coordinate of 0, whether it crosses here or here where I've drawn it, or further down at the negatives if it crosses at 0, 0, what we call the origin. Any point where it crosses the y-axis, the x-coordinate would be 0. And so a lot of times what you will see us do is you will see us just label the y-intercept using the y-coordinate because we assume that you know that the x-coordinate is 0. So I want to make sure you're aware of that we're assuming the x-coordinate is 0, and it goes back to that definition of what the y-intercept is. I know definitions are boring, but they're important. So coming back to this particular problem, the y-intercept is represented by that b value. So I'm going to channel Ms. Braswell for a moment because she makes her kids do this. When you state the y-intercept, state it as that point. So she makes her students write the point 0, 1. Other teachers, usually me, I will be okay if you just write b equals 1. That the b value is 1 and that you understand what that means. Ms. Braswell makes her students write the 0, 1. And the reason she does that, and it's a really good reason, is because it emphasizes that it is a point. The y-intercept is not a number. It's a location, and the x-coordinate of that location is a 1 or a 0. So I'm going to go ahead and plot the y-intercept. Now, to verify this, remember the definition of the graph is it's the set of ordered pairs that make the equation true. If I plug in x equals 0, remember 0 is Miss Taylor's favorite number, negative 1/2 times 0 is 0, and 0 plus 1 is 1. And so I can see when x is 0, y is 1, and that gets into what we were doing last class. And it always works that way, so you don't need to keep checking it. If you plug in a 0 for the x, whatever you've got attached to that x is going to multiply to 0, and you'll be left with that number. So the first step in graphing using the y slope and the y-intercept is to plot the y-intercept. The second step is to count. Well, I'm going to do an important fact here. From the y-intercept, you are going to count the rise over the run. So remember from like a few lessons ago that we talked about what the slope is. It tells us how steep the line is, and we have all these different ways of describing the slope, and one of them is rise over run. So if I know that the line goes through this point, and I know how steep it is, I know whether it's like gradually going up, or if it's super steep, or if it tilts negative. This one is negative, so it's going to tilt down. If I know where it goes through that point, and I know how steep it is, I should be able to figure out where another point is. Now, from the y-intercept, a common mistake students make is that they count the slope starting at the origin. You're not going to count the rise and the run starting from the origin. You're going to start at a point that you know is on the line. So looking at this, my slope is negative 1/2 or negative 1/2. And in that corresponds, that's not a word. It corresponds to the rise over the run. If you have a negative, it means that you will count down. And if it's positive, you would count up. And then on your run, if it's negative, you count left. And if it's positive, you count right. If you always put your negative in the numerator, then you never have to worry about counting left. Although you probably don't always want to do that. So according to this, I am going to count down 1 and then to the right 2. Starting from the, I didn't turn on the pointer. Starting from the y-intercept. So I'm going to count down 1 and right 2, and that is going to locate my other point. Ta-da! Step 3 is probably going to seem really silly to some of you, but just trust me, it's not silly because people don't do it. So step 3 is to connect the points and draw the line. Okay, so connect the points with a line. And by a line, what I mean is something that goes infinitely in both directions. So I will connect. That was not the best job. Let's see if I can do better. Ta-da! Beautiful. And that what that does is it saves me from having to guess and check a million other points. So I can look at this and I can actually look at like any point that line goes through. If I plug in the X and plug in the Y, I will get a true statement. But I don't have to go through that whole process of plotting all those points or guessing all those points. I'm able to get it this way. Just take a look at this. This is the point 2, 0. So if you're not convinced about the point 2, 0, so we had negative 1/2 x plus 1, right? That is the equation. And we had the point 2, 0. So if I plug in 0 for y and 2 for x, negative 1/2 times 2 is negative 1, and -1 plus 1 is 0. So that other point does work, but I didn't have to go through the process of checking it. So that's our shortcut. We are going to look at this, and I addressed this in the video, but I did not address it in a live session unless we had all kinds of extra time. So I do want to address this question here. If you've got the slope -1/2, does it matter where the negative is? And the answer to that is probably not. So let's take a look at this. So the answer to that's our question, is no. If you put the negative in the numerator, or if you put the negative in the denominator, you are still going to get a point on the line. So remember, this one was we went down 1 and right 2. This one would have us go up 1 and left 2. So let's go back over to our graph. If I go up 1 and left 2, I have not a straight line. It'll make my dot really big. It should be on the line, and the reason it's not is not because we did anything wrong. It's just because it wobbled, and my purple line is doing this little number where it bumped up. But if you look at it, the yellow dot, the black dot, and the red dot, they actually are all on the same line. Now, why would you ever want to do that? Most of the time, honestly, you don't. But sometimes when you're counting your rise and your run, you'll actually count off of the graph somewhere. And generally, you don't want to count off the graph. And so you might decide to switch it, because if your point is way up here and you're like, oh, drat, I can't go count up, you'd change it so that you could count down instead. Or vice versa, if you had a point down here and you were supposed to count down and you just don't have any space, so you would change it so you could count up. But it honestly doesn't matter. Now, before we leave that idea, what you can't do, and I'll put this, you can't put the negative in both places. Okay, that is not the same, because a negative divided by a negative is a positive, and that's going to give you something totally different. So don't even write that down. Just remember, you can't put it in both places. That will not work. Let's look at this second example. I'm going to do this one much, much faster, because what's the point of a shortcut if it takes us 12.5 minutes to use it? So going through those steps, step number 1, you're going to plot that y-intercept. That y-intercept is the value that you have there. Just take care. In this case, it's negative. Some teachers are okay with you saying the y-intercept is -1, and you would put your dot on the y-axis at the -1. We are channeling Miss Braswell, though, for the point of this lesson, and she would have her students write 0, -1, remembering that the x-coordinate of that point is 0. So it just reinforces the definition. Y-intercept is a point. The slope in this case is a 3. So you might be wondering, oh, 3. And I get this a lot. Lots of students do this. So they start at the y-intercept and they count up 1, 2, 3. And they see, oh, there's no denominator, so there's my line. I want you to stop and think about that for a moment. A couple classes ago, I said vertical lines are a thing, they're an actual thing that you will see, but they're not very common. And so if you are doing your homework and you are seeing lots and lots of vertical lines, something is wrong. So that is not the right thing to do. So I'm going to use this program and delete it. It's actually better than using a whiteboard. What you want to remember is that 3 is what's called a rational number. This goes back to our first lesson, which means it can be written as a fraction. We don't usually write it as a fraction, but we could. And in this case, we need to, because this will tell us that we go up not just 3, but we also have to go right 1. And so I will start here and count up 1, 2, 3, and then right 1. And that will give me my 2 points. Make sure you connect the points. Make sure you have arrows on the end of the line, because there's an infinite number of points there. These should be very quick problems to do. This is a problem that should look familiar. We looked at this problem in the last lesson where we made a table and plotted this, graphed this by plotting points. We're going to graph this using slope-intercept form, and this will review the concept of literal equations. The goal here is to solve for y. So we are going to solve for y, which means get y by itself. We actually want to do a little bit more than that. We don't just want to get the y by itself. We want to actually get it in the right form. We want that in slope-intercept form. So if I want to get the y by itself, first of all, you don't panic, or if you do panic, you have your 15 seconds of uh-oh, and then you resolve. You know how to do this. Math is consistent. These rules are not changing on you. So you look at your y. The y is being multiplied by a 3, and then we have out here, we have a positive 2x, which it's not letting me put the positive. There we go. A positive 2x. So if I am going to solve this for y, I'm going to start with the last thing done and undo that. So I'm going to subtract 2x. If I subtract 2x from the left, I also must subtract it from the right. 2x minus 2x is 0. That's why it cancels out. Bring down the 3y, and then we have minus 2x. Now I'm going to do a quick change here. If you remember, whoa, not like that. Okay, if you remember from my Algebra 1 teacher, because I'll tell you all these stories about like my teachers. My Algebra 1 teacher would not let us write subtraction. He made us write everything as plus negative. So he would have made us write that as 6 plus negative 2x. Now, when you have it written as addition, we're going to kick in what's called the commutative property, which we've also studied this year. And the commutative property allows us to switch the order. And so 6 plus negative 2x is the same as negative 2x plus 6. Now we're going to divide by 3. And if you divide everything on the left-hand side by 3, you have to divide everything on the right-hand side by 3. 3 divided by 3 is 1. And then there's my slope, negative 2 over 3. And I'm just going to pull the x out. 6 divided by 3 is 2. I'm just going to pull the x out. You don't have to. And if you're wondering like why that's okay, basically what I'm doing there is I'm undoing the multiplication in that numerator. And I don't mind explaining it to you later if we have to, but I'm not going to take the time right now. All right, and now using our slope-intercept form, here's my y-intercept. The y-intercept will be the point 0, 2. So there it is. And then my slope means that I will count down. Ooh, that's awful. It does not want me to write there. I'm going to count down 2 and right 3. So down 2, right 3, and there's my line. And if you really want to, you can go back and reference the last lesson, and you will see that those are exactly the same points that we ended up with before. So if we were doing this in one 90-minute lesson, this would all be combined together, and I would bring you back to that other table and say, look, we just got the same answer a different way. But it's the same problem, so we better get the same answer regardless. All right, so that's how that works. Next thing up is for you to get a chance to practice. So for 2 class periods, I've been on about different ways of graphing lines. I honestly don't have a preference. What I care about is that you are able to get the graph of a line and that you understand how you got that graph. It should not be magic. How you're getting the graph of the line. You should be able to explain to me, I got this graph by making a table and plugging in the numbers. I got this graph by plotting the y-intercept and counting the slope. What's important is that you understand it. So here are our practice problems. You are to graph the following. Y equals 4/3 x minus 3. Second problem, y equals negative 2x plus 4. And the third problem, 3x minus 4y equals 12. We will stop the video here and go over it together. Okay, for those of you watching at home who might have missed this in class and you are watching the video afterwards in order to make up the material, make up that lesson, which is a great thing about having these lessons pre-recorded, I will go through how to graph these. So for our first one, oh, I think I want that one. There we go. The first one is y equals 4/3 x minus 3. This is how fast these problems should be. I look at the y-intercept, I recognize the y-intercept is -3, and I count down 3 on the y-axis. If I were to ask you, why did you count down and not up? What are the coordinates of the y-intercept, or what is the y-intercept? You should be able to answer any of those questions, but I don't expect you to write that stuff out and think about it every single time you're graphing a line. The slope here is 4/3. So because it's positive, I'm going to count up 4, and because it's positive, I'm going to count to the right 3, and I start right here at the y-intercept. 1, 2, 3, 4, 1, 2, 3, and that will locate my point right there, and there's my line. If you wanted to, and you had the time, you could pick any point on that line, plug it into the equation, and it would make the equation true, because that's what a graph is. You could also, I forgot what I was going to say. You could also build your table, is the other way that you could do this. Next problem was y equals -2x plus 4. And again, this is how fast it is. Y-intercept is 4. Counting up, 1, 2, 3, 4. There it is. Slope is -2. Remember that that's -2/1. So that tells us we're going to go down 2 and to the right 1, starting at the y-intercept. So I go down 1, 2, and to the right 1. And just like that, I'm doing this kind of fast, and I know it's crooked. And notice the little check there. We know that the slope is negative, so we know that it should tilt this way. And I think it was 2 or 3 lessons ago, I made that mistake where my line wasn't tilting in the right direction, and so I caught that mistake, but there's your little check on that. And our last one, 3x minus 4y equals 12. I actually am going to use a table to do this, and the reason I'm choosing a table is because I have done like decades of math work. Like I've been doing Algebra 2 longer than you've been born. And so I can look at this and I recognize that there is an easy way to do this with a table. It's not more right than any other method. So if you opted for a different method, there's nothing wrong with that. But what I am noticing is that 12 divides by 3 and 12 divides by 4. And so what I know is that if I pick a 0 for x and a 0 for y, and I plug those in, I am going to get very nice numbers. So I'll work over here on the lower left. If I plug in a 0 for the x, 3 times 0 is 0. I get -4y equals 12. Divide by -4, and y is equal to -3. That says y equals -3. Like, you probably don't believe me, but it does. So y equals -3. All right. And the reason I knew it was going to come out nice is because I knew that 12 divided by 4. And I can do the same thing with the y. So I'm going to go ahead and plug in the 0 for the y. 4 times 0 is 0. So I get 3y equals 12. Divide both sides by 3. And, oh, wait, I made a mistake. It's not a y, it's an x. I was just saying y out loud. That's an x. There we go. X is equal to 4. And so I knew looking at that those numbers were going to come out good. And so I opted for the table. But you could also solve it for y. There's absolutely nothing wrong with that. 0, -3 is going to plunk me right here. 4, 0, 1, 2, 3, 4 is right there. And then we have everything in between. So that reviews the practice problems for anybody who's watching the video as makeup work or for review for the test or whatever. As we move back to full-time 5 days a week, we won't have the live sessions recorded. And so if you're absent, the video is going to be the best way for you to get the lesson. So I am going to keep doing the videos so that if you are absent, you can actually get the lesson. So that's a good thing. But there you go. And the next thing up will be your homework.